All right, so you should have done this warm-up. I want to just go over it quickly so you can check your answers. If we're looking to state the transformation, these are generic statements. They don't have to do with which function. So it doesn't matter if it's a quadratic or a square root or an absolute value or any of our other ones that we're going to learn. These all have the same effect. So if you look at this, the 1/2 tells me it's compressed. By a factor of 1/2. And the -3 tells me that it's shifted vertically down 3. Okay, this negative out front tells me it's got a vertical reflection. The 3 right there tells me it is stretched by a factor of 3. And we should probably say vertically stretched. And then inside here tells me that it is shifted left 5. Last one of those. The negative inside with the X says it's a horizontal reflection. This says I am shifted down 21. Okay, hopefully those are becoming pretty clear. Writing the equation of the piecewise is still probably a little new. So let's go through that. So I say f of x is equal to, and then I'm going to have my 3 parts. Well, the first part is a square root. It is shifted up, and it's reflected horizontally. So I'm going to have the square root of negative x, and I'm shifted up 3. And that applies when my x value is less than, and because I've got a solid dot, or equal to 0. Okay, the next piece of my graph is a quadratic. It's opening normal, so it's positive, but I can see that instead of going out 1, up 1, I'm going up 2. So it's going to be stretched vertically by 2. I'm shifted over 1 to the right, and I'm shifted down 1. And that part of it applies from 0 to 3. Open circle here at 0 says not equal to. Closed circle here at 3 says or equal to. Okay, the last part is just a line, and I can see that it is a line going down 1 over 3. Okay, so a slope of negative 1/3. And if I trace that back to the y-axis, I'm going to have a y-intercept of 2. And that part of my function, and these are both arrows, says that I'm going where x is greater than 3. Okay, so now to get into the lesson. So far, we have been dealing with quadratics just in vertex form. If you think of what we've done, we've located the vertex from HK, decided if it opens up and down based on positive or negative at the A, and located points based on whether it is stretched or compressed. So the information that the vertex form provides us with easily and quickly? Well, I would say the vertex. Aptly named, right? Vertex form tells us the vertex. If I look at this, so I would pause for just a second and do each of these to just make sure you are remembering. I'm going to go on and give you the answers. So if I'm looking at this, the vertex is 2, 5. Because it's positive, it opens up. Line of symmetry, I am shifted to the left 1. So my line of symmetry is x equals -1. And the y-intercept then is -1, 4. Okay, if I look at this last one, the positive here tells me that it opens up. So I'm going to have a minimum, and the value of the minimum is the y value, so the value is 10. Hopefully that was a good reminder of what we did with quadratics, because now we're going to expand this week and learn a whole bunch more about quadratics. So if I look at a quadratic, what else might I want to know? So right now we said what we do know is the vertex from the vertex form. What else might we want to know? Well, there are important pieces, and in math it is always important to understand where you're getting parts of your graph that are important, and those important parts are usually where I'm crossing the x-axis and where I'm crossing the y-axis, so the intercepts. We're going to focus today on where we cross the x-axis. All the points on the x-axis have not moved up, have not moved down, so they have a y value of 0. Super, super important to understand and make sure we remember this for everything. Points on the x-axis have a y value of 0. So again, if a parabola crosses the x-axis like this, or like this, doesn't matter which direction, the y value of those points must equal to 0. So we can find the x-intercepts by factoring, that's our good friend that we know from Algebra 1, and solve for x when y equals 0. Okay, so let's just go over a couple of different forms of quadratic equation. We already know the vertex form. Today we're going to look at both the standard and the factored form. Slides again that are in blue are important, and you may want to add this to your notes if you don't know it. So the standard form of a quadratic equation is ax squared plus bx plus c, and that's equal to 0. And obviously the a cannot be 0 because otherwise you wouldn't have a quadratic. When we have it in this form, we can find and here's several different ways of kind of talking about the same thing. We can find the solutions, which you will also hear referred to as zeros, roots, and x-intercepts by factoring. So we're going to use standard form. We're going to find those things, the solutions, zeros, roots, and x-intercepts, by using factoring. Factored form is when we go from that trinomial to these two binomials that are multiplied times each other. So these parts right here are going to help us to understand the x-intercepts. So again, blue screen, factored form, that's important to us. So what we're going to work on today is how do I go from standard form to factored form? Well, we do that by factoring. These are a set of trinomials to factor. They all have a leading coefficient out here of 1. So I am hoping that you remember these. So I also saved this as just a single sheet if you want to take a moment between videos and practice each of these.